Hello, my name is Michael Cooper. In this project, I will demonstrate how machine learning can optimize crop yield forecasting in agriculture. So what's a problem statement? Farmers face unpredictable weather conditions, varying soil quality, and inconsistent resource allocation, which makes it difficult to accurately predict crop yields. Um, so this leads to inaccurate forecasts, which can lead to resource mismanagement, financial losses, and inefficiencies. And to address this, the idea is to develop a machine learning model that can predict crop yields using a combination of historical weather data, soil quality metrics, and satellite imagery. So this solution would help farmers make data-driven decisions about planting, irrigation, and harvesting schedules. Um, so what is the key task? First of all, to accurately predict crop yields. The input data would include the weather data, which is temperature, rainfall, and humidity, soil quality metrics, pH level, nutrients, contents, and moisture, and satellite imagery used to assess vegetation health in certain areas. I would also look at historical crop data for model training and validation. The challenges that we would face, first of all, there's variability in weather patterns, which would make predictions difficult. Also, the farmers often lack access to real-time insights and data. And there are data silos that prevent the effective combination of weather, soil, and satellite data. So the opportunities for improvement here are automation of data aggregation and analysis that would improve accuracy and simplify the task flow in a user-friendly app that we would offer that would offer real-time and actionable insights. As far as user experience design, the farmers would use a web or mobile application to interact with the solution. They can enter the crop type, the planting date, and the farm location in the system. And the app would display the yield predictions with confidence intervals and other recommendations for irrigation and fertilization schedules. As far as user experience considerations, the farmers would need to input their farm data in the system along with the real-time weather and soil data. And the system would include feedback loops where farmers could report actual yields, helping the model learn and improve over time. The app would also display the accuracy metrics. The farmers also could view the data sources and how factors like rainfall and temperature influence predictions. And this would increase the truth and interpretability of the model. As far as communicating uncertainty, instead of a single value, the model would show a prediction range. So from X to Y tons of production per hectare, the confidence bands on the visual charts would show the range of possible outcomes. And then the farmers would receive alerts for uncertainty scenarios like unpredictable weather. As far as privacy concerns, like ethical and privacy considerations, the system will collect location data, satellite imagery, and soil metrics. The data would be encrypted and anonymized, and the farmers would choose whether to share the data with third-party weather services. So that question that usually you get asked on whether or not to share your data with third-party vendors, it's a standard question for applications, would be added to this. In Europe, the model complies with regulations, ensuring that farmers would be able to delete, view, or opt out of data collection. And in the US, the model would show how the data is collected and give the farmers the option to request the removal that would make it compliant with US practices. As far as ethical principles, the model will use diverse data sets So using crops from different regions to minimize bias. There would be regular bias audits to prevent skewed predictions. The farmers could report inaccuracies through like a reporting system in the app. And there would be human oversight on the model to ensure transparency and fairness. As far as transparency, the model would display the confidence scores and data sources, so just to understand the right reliability of the predictions. And then the model will include an explanation on how weather and soil metrics influence the output. So that's it in a nutshell. Thank you very much. Bye-bye.